Welcome to this walkthrough of the Moddable Holiday Wreath. It's an IoT-powered wreath using an ESP32S3 with 100 neopixels and a speaker you can probably hear playing in the background. What's really interesting about this project isn't the hardware though, it's how the software was built. We built it using Node-RED for microcontrollers, Node-RED MCU Edition, which is something new this year. It lets us build JavaScript-powered projects that run on inexpensive microcontrollers instead of requiring, for example, a Raspberry Pi running Linux and Node.js. So I'm going to show you how we built that project. You can see the Node-RED editor up on the screen in front of me. I'm just going to kind of walk through the different nodes and flows that were used and show you some of the techniques. So at the start, we have the initialize flow. This is triggered by an inject node that runs immediately at startup after 0 seconds. And it sets up a bunch of variables that are stored on the flow. You can think of the flow as sort of a global variable that holds different bits and pieces of state. So here we have the neopixel node, which is the current animation mode, which gets initialized to random. Here we have a list of what the different animation modes are. That's stored on neopixel's nodes, and there's 3, wipe, random, and sparkle. We also store a list of all the songs that can be played. That gets a little messy here to try to type this into the tiny box. Fortunately, Node-RED has a really spiffy JSON editor that you can use to define that very easily. It's really helpful, especially if you're not like an expert at typing JSON correctly. We also initialize a pixels array. This wreath has 100 neopixels in it, and so we initialize an array with 100 elements, set them all to 0, which is off to start, and store that on the flow so that any of the code that runs elsewhere here has access to that pixel array. At the end, we send a debug message. This is using a debug node labeled initialized. And that is used as a kind of a trigger for all the rest of the parts of the flow to let them know that they should start running. I'm going to just restart this. So when this initialized node runs, it sends what's called a complete message out to everybody else, and people can listen to that. Other nodes can listen to that. And one of the things that listens to it is this step animation. So this is a complete node, and it's listening for initialized to be complete. When that happens, it propagates a message to this switch node, which looks at the current animation set on flow. Remember, we initialized that to random. And it sends the message on to one of the other outputs based on whether it's equal to random, wipe, or sparkle. If it's not, it sends it to off. And so here you can see each of these nodes. And so this is a kind of a way, it's called switch, to choose, like you would in a JavaScript switch, which piece of code is going to run next. So only one of these will run, and we kind of treat off as the default. So the random colors node, for example, runs a bunch of JavaScript to, at the end of the day, choose some pretty looking random colors that will get displayed on the wreath, and then here it propagates that message onto the next node by returning it. Off is a little easier to understand. It just sets all the pixels to black and then propagates that through. Whichever of these runs, it then sends the message to the neopixels node, which is defined to have 100 LEDs connected to a certain pin and so forth. This sends the pixels to the wreath to display the colors that you're seeing here. And then once it's done, it also sends kind of a complete message. And that complete message is also listened to by the step node. So it's listening for the 100 neopixels node and the initialized node to be done. And that then triggers the next frame to be displayed. This is a really great technique so that you don't have to know the actual frame rate that the wreath is running at. However fast it runs, the complete message will be sent and trigger the next frame at the right time. For those of you who do animation on the web, this is a little bit similar to the request animation frame callback, which is something that browsers use to throttle animations to exactly the frame rate that the display they're connected to is running at. And so here we're kind of borrowing that idea, but applying it to animating lights on a holiday wreath. So once those lights are animating, you notice they change the flow occasionally, and there's different ways that that can happen. The first way is using a timer that runs once a minute, and so that's just using an inject that sends a message once a minute. The message itself is empty. We don't care what it is. It's going to cause this next node to run, which chooses a number between 0 and 2, so 0, 1, or 2. That's the number of animations that we have. Remember, random, wipe, and color. That goes through a change node, which does an array lookup. So this is kind of interesting and saves the need to have a function node. So what this does is it says, hey, the payload has a number from 0 to 2. We're going to get the array that's on NeoPixel's nodes. That's the different animations, and we're going to look up using array notation the ith item, the item 0, 1, or 2, and so that will then give us a string with the name of the animation. That propagates through here to set the animation on that global flow NeoPixel node that we talked about before. And then eventually what happens, of course, is that here, this loop runs again, and animation has changed, flow NeoPixel's mode. And so then we begin animating the next animation. Super straightforward. I'm going to skip this publish node for a moment, and we'll come back to it. I want to look at another way to change the animation. So this ESP32 S3 module that we're using has a couple buttons, and this one down here is user programmable, you can see. And so what we're going to do is use a button node. It's kind of borrowed from Raspberry Pi. We'll connect it to button 0, which is the GPIO, is the pin of this button. And when that's pressed, it's going to send a message, and the payload of that message will be either 0 or 1, depending on whether it was pushed or released. And so what we're using here is a switch node, and this is kind of another neat trick to avoid writing some code and just staying within the Node-RED interface. What we say is if the payload is 0, then we'll propagate the message down, and that's when the button's pressed. If the payload's something else, like 1, which means that the button went up, then the message won't move on any further. And so this allows us to have a response just to the button press, but to ignore the button up. So when the button's down, it runs a function node that chooses the next animation, and this just goes in sequence based on the contents of the NeoPixel's modes. And then that sets the animation, which causes a wreath to update. And so we can see how that works. You can see here I'll press the button, and you'll see the wreath goes to wipe, then the wreath goes back to random. If I press it again, we'll go back to sparkle. So you can see very easily and very quickly that flow updates the lights. Now, every time the lights change, there's this other node that runs. So the set animation propagates here to this MQTT out node. And this is connected to an MQTT server, mosquito.org, which is a great test server. And it sends the payload, whatever that is, which is the current animation in this case, to the topic Moddable Wreath status animation. And so anybody listening on this server to this topic is able to see the animation that's currently running on the Moddable Wreath. So here we're running the random pattern, as you can see. And if we come over here to my command line, I'm listening to that very server, test.mosquito.org, using the mosquito sub command line tool, and it's telling me, hey, we changed to random. If I come back here and press the button again, see it changes to sparkle. And here it's showing me now it's running sparkle. And so with just by dropping this one block into the flow, we're now able from anywhere in the world to monitor what's being animated on this IoT wreath. Now we can also control this wreath using MQTT. And to do that, we just have to add one more node. So this is an MQTT in node. It listens to the same mosquito.org server, and it subscribes to a topic Moddable Wreath set animation. And when that comes through, it just propagates it through to set animation. And so I'll show you here, we can come back to the command line, and I've got a command line here to set that property using mosquito pub. And so we'll turn that to, let's say, sparkle, since it's now on random. And you'll see sparkle come through. And now the wreath is sparkling. If we set it to, we can send off. You see it's off, and the wreath has gone back to being off, and will now return to random. So again, very simple, with just 2 nodes added to this flow, we have remote monitoring and remote control of this wreath. And that's all built on standard JavaScript modules that have been automatically connected together by Node-RED. And what's kind of cool here is how simple it is, just by wiring in a couple blocks and filling in some configuration data, that we've now connected this wreath out to the world with these capabilities. So let's move on and look at the song streaming. You've been hearing this in the background. Let's take a look at how it works. So if you remember up here, this initialize node is run when the initialization is complete, and the step animation listens to that. Well, the next song also listens for that, and it says, hey, when I'm initialized, it's time to start the next song. And it pumps this through the switch node. We'll skip that for the moment, but in the usual case, what happens is it picks a random number from 0 to 9, because there's 10 songs. And then, like the animations, it goes and looks up on the songs array that number from 0 to 9 to get the URL of the song. It sets that on the message wave property, which is what the next node wants to know where to stream from. And here we use a node that was built specifically for Node-RED MCU Edition that does HTTP streaming and other kinds of audio playback. It receives that message, and then it begins streaming that song. When that song is done streaming, this node sends out a complete message, which is caught again by next song, because it's listening for complete messages from stream song. And that then causes the next song to start streaming. So we have here another example of kind of using the complete capability of Node-RED to rate limit the songs so that it plays one back to back and they don't interrupt each other, and we don't need to know how long the songs are in order to make all that work. It also publishes the currently playing song out to MQTT. The only thing we have to do special is move that wave message to payload, because that's where MQTT is looking for the message by default. And then that publishes it out to this URL, to Moddable Wreath status song. So if we come back to our monitor here, you'll see it shows the name of the current song, or the URL of the current song that's being played. If you grab these URLs, they really will play in your browser just like they do on our wreath. We also wanted to be able to control the song that's playing, just like we control the lights that are playing. And so to do that, we use another MQTT in node, this time listening to the set song message. And that propagates the requested song through to the audio output. And so let's come over here to terminal. And in this case, instead of setting the lights, we will set a song. And this is kind of a loud one, so maybe you'll be able to hear it. Let's pick a different one, actually. And so there you go. So we can change whatever song is playing. And that status gets echoed out because that's a new song being played, and the music gets updated immediately. And so again, a very simple way to add remote control to a project is using MQTT nodes in Node-RED. There's one little trick to mention here, which was a little interesting to work out, which is when you receive a new song request, we set a Boolean that says, hey, there was a song requested, and that Boolean, so what happens is there's a song already playing when you have a song requested, and so this is going to issue a done. It's going to say, hey, I'm done playing the last song, I'm starting to play the next one. And if what we then did was choose a random song, we would immediately skip past the currently playing song. So what instead we use is we say, hey, we set this Boolean on the flow that says somebody requested a song, and then in the switch, if somebody had requested a song, we just clear the requested song instead of that variable, instead of choosing a new song. And so that kind of lets everything work. It's a little tricky. It's probably the trickiest thing in this flow, but it does let us get the result that we want without using too many blocks or too much trickery. So that is the entire project. It's kind of cool. It almost fits on a screen if your screen's a little bigger than mine. So it's not too complicated, but it brings together a ton of stuff. NeoPixel lights, button controls, streaming audio, remote monitoring, remote playback, even error handling. If the node fails, if streaming fails, it will automatically restart using this error node. So really powerful stuff that can be wired together in a very visual way that lets you use your JavaScript skills to code the unique parts, and then fall back on kind of Node-RED to wire it all together and take care of the logistics of talking to the hardware and talking to the network. So I hope you've learned some useful techniques from this. It was a lot of fun building this project and thinking of ways to make it all work. I'm a bit of a Node-RED novice. If you're a Node-RED expert and you're looking at this and you have much better ways to do it, I'd love to hear about it. If you have questions about how this worked, I'd also like to hear about it. You can reach out on the Node-RED repository. It's here on GitHub at photty/Node-RED MCU. You can file issues, you can ask questions and discussions. I'm happy to help. So thank you for listening.